Hello, welcome to a new episode of the MBSE podcast. We have already talked about the next generation SysML v2 in some episodes with Ed Seidewitz and Sandy Friedenthal and so forth. And we also mentioned that there will be an API, but we haven't talked about the API in detail yet, as far as I remember. So technically, well, it's just an API, but it has the potential to be a game changer in MBSE. So it's time to talk about it. And we have the perfect guest to do that. Just last week, we saw each other live at the OMG meeting. I think it was last week. And well, now I'm delighted that Manas took time. And Manas is one of the masterminds of the API, so we couldn't have a better guest to talk about it. And since he knows himself better than I know him, he can introduce himself. So Manas, please introduce you.
Hello, Tim and Christian. Thanks for having me on your podcast. I really appreciate the opportunity to talk with you today. For my audience, my name is Manas Bajaj. I'm the co-founder and chief systems officer at Intercax, leading provider of digital thread and digital engineering products and solutions. In my other role at the OMG, which stands for the Object Management Group, I lead the development of the Systems Modeling API and Services 1.0 specification, often referred to as SysML v2 API, although the scope is much, much more broader than SysML v2. I led the development of the RFP, which was released in 2018 by the OMG. And since then, I've led the development of the specification and its pilot implementation at OMG. And I'm really excited to share that we're very close to having the Systems Modeling API and Services 1.0 beta specification to be finally adopted and released on the OMG website. Should happen anytime this week or next week.
These are very good news. So maybe, Manas, we should clarify for our listeners who are not so deep into IT stuff, what is an API and what is the SysML v2 API?
Great question, Christian. So an API is an acronym for Application Programming Interface. Just like we as human users, when we interact with a piece of software on our computers, we use a graphical user interface. When you're accessing Microsoft Word or Excel or a SysML modeling tool, you're playing with the user application and the UI. And similar to that, softwares and services interact through APIs. So think of the API as a port on a software that allows other software tools to interact with it. In the modern world, we say data is a new oil, right? And APIs are the pipelines that carry that oil. Without the APIs, data really can't flow freely. And so if you have a tool or if you have a service that doesn't provide an API, it becomes very difficult to get data out with that service and do something like reasoning with it, analyze it, and put it back. So APIs are kind of the pipelines that makes things flow. SysML v2 API provides a standard API for performing create, read, update, delete operations on SysML v2 models. And in general, any kernel-based meta model. That provides a standard API for configuration management of these models. And for API users and application developers, provides a standard way that you can develop apps and scripts to do fun stuff with SysML v2 models in a completely tool and a platform neutral way.
Mm-hmm. Cool. I like the comparison with the pipeline. That's a pretty good picture of it.
I hope that sticks.
Yeah. Okay. So, well, and now SysML v2 is now the new version after SysML v1. Was there also an API for SysML v1?
No, there was not. It was the first time that the systems modeling language or the unified modeling language, Rich standards, or I think even BPM, and it says having an API of its that is coming with the language itself. Mostly OMG standards are focused on language models and language meta models. This would be the first, one of the first times that there'll be an API that is coming with the language meta model.
So what was the motivation to create the API?
So there were four major problems that were spelled out in the RFP for the API, and these were pretty big ones. The first, that there was a lack of a standard approach for programmatically interacting with SysML models. The standard approach for working with SysML or UML models was that you could export an XML file out of that modeling tool, which may or may not be read in all of its totality in another modeling tool. And file-based interchange doesn't really scale up to moving data at fast pace or moving large amount of data or enabling data streams in the modern enterprise, especially as models and data is constantly changing. Imagine you change a model, you export an XML file, you change the model again, you have to export another XML file. And the receiver application has to somehow process what changed between the two XML files. So it's very dirty to kind of play with file-based exchange of data across the modeling tool. So that's what an API was needed. That was one of the big drivers for it. Second, to solve this issue with XMI, which was not really scaling up, different end users and app developers were using the native APIs of the UML and SysML modeling tools. And they did a good job at providing these APIs, thanks to all the UML SysML vendors tools. But these APIs were defined in different programming languages. So if you're working with a tool that is Java-based, you could only use a Java API. If you're working with a tool that's not .NET-based, you can only use a .NET API. And so if you write an app, it was not really portable. I could write an app or a script that takes data out of a SysML v2 model and generate reports out of it. If my company or my organization adopts another SysML or UML modeling tool, I had to literally rewrite the app. The same app won't work. So now I've got multiple versions of the app, one for each SysML UML modeling tool with the native API. So that really was a big headache. You're spending more time and resources in managing these different versions of your scripts or apps versus focusing on the core business logic that inspired the app. Third, and I think more big, was that as MBSE evolved from a core group of system engineers to a broader enterprise, the enterprise IT was kind of surprised to hear that there was not a standard data stream or an API for system architecture models. I mean, we have to understand that system architecture models are kind of the blueprint of a system. So it's not just the systems engineering teams who need to use it or consume it. It is something that should be made available to all disciplines. And so not having an API was kind of hindering that process of adoption. And finally, I would say that the fourth challenge was that organizations are building systems. And these systems mean that they have to define not only the architecture of the system, but they have to also think about the hardware, the software, the test, and the requirements, all data that's related to the system. They have to build a digital thread as a foundation for a digital twin of the system. And you can't build digital threads by throwing files across the firewalls. You need a data stream, you need an API that could serve the system architecture model to be made available to teams that are doing hardware design, software design, verification, test campaigns. And so these kind of are the four major challenges that inspired the OMG to issue the RFP and then led to the SysML v2 API and services specification as we talk about it.
Okay, great. Yeah. So Tim already called it as a potential game changer. Can you give us maybe some examples how the game may change it?
Oh yeah, it's already changing, I feel. So one of the ways I mentioned the systems modeling API and services is responding in a big way to those four major impediments. So you're going to have a standard API to write new apps and new services. If your organization is using multiple SysML UML provider tools who have adopted or are conformant to the SysML v2 standard API, you could write your app once and run it on all of them, right? Imagine taking system architecture of subsets of the system from one tool and imagine using that same step to take it from another tool and just doing analysis with it. How liberating is it for someone who's trying to automate the process of analysis and design for system architecture? So that's a big game changer. A lot of time and resources that we would save in doing so. Also, the fact that system architecture models being available through an API could make that broadly accessible to the rest of the enterprise in a live mode without throwing files across the boundaries. And we could create digital threads as a foundation for digital twins for a project system where the system architecture model is available as a data stream. I actually just demonstrated that last week at the SED SIG meeting, showing that how we can start building a digital thread for a spacecraft using the standard SysML v2 API. I also feel there's another impact of this, which I think we'll realize maybe in a few years from now. I feel this is going to open up the marketplace for providers and consumers of the API with specific capabilities. For example, if you're a company or a software vendor that has a report generation app or has an analysis app or has an app that does very stunning visual presentations, you could, if you have a new idea, you could build an app or connect your app to the standard API without worrying about what file to take, what vendor tool that you will adapt and work with it. So we might see a lot more tool providers enter the market, not just for modeling purposes, but kind of to do other things that system engineers need, like report generation, analysis, visual presentation, long-term data retention, automation. These are all kinds of solution providers that would not be welcome. And so I think it's going to open up the marketplace for vendors. It's going to open up the marketplace for end users and options the users are going to have. Overall, a win-win for product vendors as well as end users.
It's possible to create smaller apps, no? So there's no need to build this huge SysML editors that can do everything and store the stuff like the common SysML we want tools. And these are big things. You do not develop such a thing in a few weeks or months with a few people, no? But now we can create small apps that are for specific tasks and really helpful working on this API.
That's right. That's exactly right. I mean, there will be tools that do a lot of things, but then you're also allowing now vendors of niche capabilities to also enter the market and do that niche stuff that they're very good at, right?
Yeah. A public example, I guess, is here Tom Sawyer. No? They are experts in visualization, and they have no product yet, but they have a prototype accessing the SysML v2 API to do the visualization of the model.
That's true, and I've personally burned through this experience myself. We have an app called Syndia, which is a digital thread application. We literally had to develop our own common API that works with multiple SysML tools to build that app. And we were spending a lot of time making that app, adapt to the different APIs that it had to work with. And so something like this could make our job easier as building a digital thread application. And I think it's going to make other vendors could really, really benefit from this, especially now that's part of a standard.
Yeah, that's cool. So simply said, SysML v2 has three interfaces: the textual notation for humans, the graphical notation for humans, and the API for our new colleague, the machines.
Yes,
so they are also now at the table. But can I use as a human also the API? Does it make sense? And how can I access it? Or do I have to be a programmer to use it?
Right. So typically I'll answer that in two ways. So yes, you as a human, we call them, the way that we categorize it is as end users versus API users, or GUI users versus API users, right? So there are a lot of application developers who are writing apps or testing applications. We call them API users. So typically when they interact with before they write apps or before they kind of set up any kind of automation, they might be, as a human, they would like to try out the API and see, hey, what calls do I need to make? What requests can I send to that piece of software, and what kind of response that piece of software can give me? You kind of try it out, test it out by sending those requests and seeing and visualizing the responses. And then when you are happy with it, you know what you need to do. You can write a script that automates it, runs in a pipeline, runs on a scheduled basis, or build an app for it. So today you can use this, right? It's available that human users could test out the API and then make sure it's part of that they verify it before it becomes a part of an application.
Yeah, so since the early days of the public releases, your company hosted a public repository for these models, and so to say, a first prototype of the API. And you're offering something called Swagger in the former times, or Open API. And can you explain our listeners how they can play around with this tool with the API?
Okay, so that's a good question, Christian. So the SysML submission team, which is the team that submitted the standard to the OMG for adoption, which now has been accepted, actually, as part of its development, while the standard was being developed, also built something called a pilot implementation. And this was done by the SysML v2 submission team as a whole. And in simple way, a pilot implementation is nothing but saying, well, we're going to propose a standard. Let's test if the thing will work. Why propose a specification in a PDF file when we cannot guarantee it's going to work? So let's implement it. Let's act as a provider. Let's act as a vendor tool and actually implement the API using a standard database or a standard web service and see if we can make this thing work. And that's typically what a pilot implementation is. So the SysML v2 submission team, also known as the SST, built a pilot implementation of the API. And we at Intercax provided servers to host that pilot implementation. We've got a dev server. We have a server that's available to the SysML v2 submission team for testing, but also it's available publicly. There's a server that's available publicly. So any end user who's outside the SysML v2 submission team can go to the public server. And when they go there, they will see, they used to see a Swagger doc, but now it's called Rappy doc. But that's basically a visual rendering of the Open API specification, which is standard for describing REST or HTTP APIs. And that's made available. So you could actually start to use it right from the documentation of the API, like, for example, get me projects that are sitting on the server, get me the model elements, and so on and so forth. But you can also use it because the SysML v2 API or the systems modeling API is available, also available as a standard REST or HTTP API. You can use it from any modern programming language. You're not bound to a specific programming language, and you can write scripts and play with it. And so we have been having a lot of users who are not part of SysML v2 submission team, but trying to experiment the API and who are hitting that server and trying it out.
Mm-hmm. And how can I get my own models on your server? Or
I said so the way you do it is that typically there are two ways to do it. One way is that if you are using the textual notation for authoring the SysML v2 model right now, so you're probably using the Jupyter site that's opened by OpenMB, and I know, Tim, that you help host another one. So if you're using the textual notation, when you publish the model, the model gets published to one of those pilot implementation servers that's made available. And so once it's published there, you can use the API to extract the data from that model directly. The other way you could do it is that, which we've demonstrated as part of an API cookbook, is that you could actually use the API itself to create a model, create a project, publish it on that pilot implementation server using the standard API, and then also access it. So you can do it as part of taking the textual notation, publishing to the repository. You can also do it as part of taking using the API itself to publish the model.
Okay, so well, if I use the API or through the API, a model element has a URL. No? It's like a website, a URL for a model element in the model.
Correct.
So anyone can access it. So well, I need some access management. No? So I would not make all my models open to the public. So how is this done?
So right now, just to keep boundaries, the systems modeling API and services, the way it was defined in the RFP or the OMG called for it, identity and access management, or I should say authentication or authorization, was not part of the scope of the standard. And there was a good reason for that. And the two that I want to clarify for the audience is that there are already multiple standards for authentication and authorization in the space, which are being used and adopted by enterprises such as SAML, OAuth, LDAP, and others. And the providers or the vendors who would implement the systems modeling API and services already have an environment, already have a piece of software that would implement the API, and they have authentication and authorization capabilities baked into the environment. So it would have been overreaching for the systems modeling API and services. Hey, let's invent a new identity management solution. So that's the reason why authorization and authentication was not part of the scope of the systems modeling API and services. That's not something that this API is trying to standardize. However, you can take any of the authentication authorization protocols like OAuth or SAML and combine it with the systems modeling API and services. The pilot implementation that we are hosting as part of the SysML v2 submission team, that doesn't require any authentication right now. We could envision a basic auth on that, but for the sake of proof of concept of the API alone, we have not implemented that as part of the pilot implementation.
Maybe one more question in this area. So I'm not an expert of these technologies, but is it possible to have access management then on the model element level? So for example, I have a part in the SysML v2 model, and I'm interested to provide the part, but not the details of the part.
Right. So there are two-pronged answers to that question. So because the systems modeling API and service is not bounding at what level you want authorization authentication to be controlled, any provider could do whatever however they feel like. But I think a general starting point would be that in the systems modeling API and services is a concept of a project. And generally speaking, in most modern enterprises and applications, authentication authorization for users is defined at the project level as a starting point. So you would say that these users have access to these projects and they have read-only access to these projects. So they can fetch data, but they cannot create new commits in the project. They cannot add elements or update elements, and so on and so forth. Or they could add and update elements, but they cannot delete stuff. That could be a possibility. So that's one level to starting down. But it is not unimaginable that a provider could offer new capabilities where they could enforce authentication layer to get into the individual commits and saying this user has access on this project, but they can only read specific baselines of the project or tags on the project. They cannot read all the commits on that project. So it's obvious to do that. And this answer is also one of the reasons why the systems modeling API services did not want to enforce standardization, because it allows vendor applications and providers to innovate in this space, right? Innovate and think of ways in which we could control who gets access to the data. Another thing I want to point out is that I think the SysML v2 meta model also has capabilities that you could have classification markings on individual elements, right? That is a provision allowed in the meta model where we could provide tags on individual elements where we could say, or annotations that say this is classified or unclassified, or this is this is restricted to certain kinds of users. So there are ways to do that in the language itself, and so a provider solution could use that and use that as a way of defining policies and authentication rules of who gets access to elements that have those markings.
So you already mentioned one binding. It was REST over HTTP, and the initial submission also drafts a second binding. It's OSLC, but there seems to be something behind it. So I think you call it a platform independent model and a platform specific model. So can you tell the listeners something about it and what will come in the future, maybe?
Right. Great question, Christian. I think it's very foundational to the way the object management group or OMG develops any standard for that matter. At OMG, specifications are defined using a platform independent layer and one or more platform specific bindings. And I personally feel, after having gone through this process myself, it's a really excellent approach because it allows us to define standards in a technology or a platform neutral way and really opens up to allowing multiple technologies, multiple standards to realize the same specification. So the systems modeling API and services 1.0 specification also follows this approach of a platform independent model and platform specific bindings. So there's a platform independent model, which is also called the PIM, that provides a logical definition of the API. It states, what are the services that the API makes available? What are the read, update, delete, or create calls that you could make for each of these individual services? Without specifying how these services are to be implemented or what protocol that they will be implemented or what technology or they'll be implemented, which I think is great because for end users, this platform independent model provides a way that they could see if the capabilities that they need are being realized by the standard or not, right? Without getting too bogged up in the individual technologies that are used to implement. And the first version of the specification also provides two platform specific models where that same PIM, the same set of definitions of services and operations is implemented or mapped to a standard REST over HTTP API and also mapped to an OSLC API. So what is included in the specification is a platform independent model, two platform specific bindings, and a mapping between the platform independent model to the platform specific binding. A provider tool could implement both the REST over HTTP API and the OSLC API, or choose to implement one over the other. And there's also a scope for a provider tool to propose new bindings, right, in the future, or they could claim conformance to the platform independent model. But if they do so, they have to provide that platform specific model.
Oh, did we lost him? Yes.
To a dedicated Java API for it.
Manas, we lost you for some seconds. Maybe you can repeat the last 10 seconds.
Sure. So I was saying that the standard provides a platform-independent model and two platform-specific models of the API, the REST over HTTP API and the OSLC API, and also a mapping between the platform-independent model to the two platform-specific models. It also opens up the way for providers to, propose new bindings or new platform-specific models in the future. But a given SysML v2 API and service provider would claim conformance to one of the PSMs, the REST over HTTP PSM, or the OSLC PSM, or even both.
Mm-hmm. So REST and OSLC bindings are part of the standard, so they are normative, and any other futures bindings are not part of the standard, or not yet, maybe in the future, but not yet.
Exactly. And the standard has conformance levels that are defined based on for each of these bindings. And I think in the future, you could propose new bindings and submit to the OMG for possible consideration. But this is really key because if I'm an app developer, talking in terms of end users, if you're writing a script, you would typically use either one of the two APIs to write your apps or write your script, or you could use a combination of the both if you really aspire to do that. And that's why it's very important that conformance is defined at the REST over HTTP API level. So imagine this, and I'll give you a simple scenario which makes it easier to understand. If I write a report generation app that takes a REST over HTTP API, extracts the data from a SysML v2 model, and generates a table of interfaces of ports in my architecture, I want that script to work with multiple providers. So if two providers provide or conform to the standard REST over HTTP API, my script or my app would work seamlessly for both of them, without writing or changing a single line of code. The business logic, right? I don't have to rewrite the app. I would extract and get stuff out of it.
Okay. But at the beginning, you presented this image of the oil pipelines, compared the API with that. So now when I tap now into such a pipeline, I don't get oil, I get data. But how can I be sure that I can do something with it? So what's the format of the data? So I retrieve it, but now I also must. But is it SysML v2? So how does it work?
Yeah, that's a good question. You want to make sure that you're not getting ones and zeros at the other end of the pipeline.
Yes,
because we want people to understand it. No, so the standard I/O input/output payload for the REST over HTTP API, for example, is JSON. We also support JSON LD, also which is what's required for the OSLC API. JSON stands for JavaScript Object Notation. Think of it as a new age XML. In the old days when apps were being written, XML was the way in which data was transmitted. But now it's JSON, which I personally feel, and I may be biased, but it's much more human readable than XML. So when you send a request to the API and say that I want to create a project with this name, or I want to create an element in a project called a spacecraft in this project, then you would send the request to a URL and you would provide the input information in a JSON format, which is very human readable, as I mentioned. The provider tool would listen to that request, interpret if it's a valid request. It will create the project and create the element called the spacecraft in there and respond the data back to you, again in a JSON format. So with a status code saying, was the request passed, or was it, was it accepted? Did it process it, or did it fail to process it? So based upon the status code at the receiver end, you could figure out, the provider tool was able to create a spacecraft model or project and was able to create an element in it. And here's the JSON, which told me what it is. And that JSON response you get, or the one you send, the way it's defined, it's actually compliant with the SysML v2 meta model. So the format of the data that you're trying to create, if you say I'm going to create a part usage or a requirement usage in the project, that's defined by the meta model. So if you send it garbage, which is not, or try to create an element which is not a standard element type in the SysML v2 meta model, a conformant provider of the API should reject that request as a bad request and say, you're trying to create an element which does not conform to the meta model.
Okay. And you mentioned the services quite sometimes in the last half an hour. Maybe it makes sense that we give our listeners some examples. For example, let's say the project versioning service and the query service, to give them a feeling what the services are about.
Yeah. So one way to think about it is that the API offers lots of capabilities, right? So instead of listing all the capabilities, one by one, we've grouped them into what's called services, right? So for example, there's a project service, which basically has operations defined for things that you want to do with a project, like, for example, creating a project or updating the name and the description of a project or getting access to all the projects or getting a project by a specific ID and so on and so forth. And so these are defined in the platform independent model as logical groupings of requests that consumers of the API can send to the providers of the API. That's one way to do it. And then, for example, you talked about, Christian, the project data versioning service. So that's another service that's defined at the logical level, saying it has operations for creating commits in the project, which means creating new versions of that project or accessing elements at a specific commit or creating branches or creating tags, which is like establishing baselines. There's also a query service, for example, as you mentioned, which has requests or operations defined for creating a new query or executing a query or creating a library of queries and so on and so forth. And these are defined just for the sake of logical grouping, but also they're very important because we have conformance criteria that's defined in the standard, which is tied to these services. So for example, you are a provider tool, you don't have to implement all the services, right? You don't have to be conformant to all the services. You could easily say that I'm conformant to project service and query service, but maybe not to some of the other services, which means that you must implement all the operations that are defined for those services, and you will not implement the others. And that's okay, because as a consumer of the API, when I interact with that provider tool, I will know that the query service is made available. And so the calls will work or will not work. So that's a way to defining, providing logical grouping of things you can do with the API, but also defining conformance levels. I think it's also important in terms of expanding the market, as I was talking about. You could have lots of providers who could come who don't implement the entire API, but implement one of the services, because that's the niche area they want to play. Let's say you have a very smart query engine and they implement the query API, right? That's good. They provide that niche capability for that one part of the API.
In SysML 1, I have the profiles to extend the language. In SysML 2, we also have a language extension mechanism, and there are also standards like URF or RAML and other ones. And is there also a possibility to extend the API in such a standardized way? Or is it just another service, but completely independent of the standard?
Yeah, I think it's a good question, Tim. So right now, because the first version of the specification, the services are pretty at the basic level, right? As in kind of the first step towards to the full power that we want to achieve. But it's a big, as I said, one small step for man is giant leap for mankind, right? So along the analogy, it's a small but a very crucial step. So the SysML v2 API, or I should really start using the word systems modeling API and services, is defined at a level where it offers a lot of the core capabilities that we need, and you can definitely extend the API going forward. One of the things I want to mention is that the way the API is defined is that it is broadly applicable not only to any kernel-based meta model, but other OMG standards that might go along this way as well. This was one of the requirements from the RFP that because you're building a first-class API for a standard like this, we do it in a manner that other OMG specs like UAF or BPMN, if they go this route, that this API would work for them. So we have the concept of a common concept of data in the API, and the kernel element is this next realization of the data. So you could have other specs coming along the way, which also realize this common data interface that the API depends upon, which means the API, all the capabilities of the API would also work for them. So that's
other specs can also define services then. So for example, a URF based on SysML v2 maybe in the future can also define services for the API as part of the URF.
Potentially, yes. There could be a way that they could define more domain-specific services that extend or build on top of the API, and we could potentially standardize that as well.
Yeah. Oh, okay.
Yeah, another cool thing that you mentioned before is the API Cookbook. Can you give us some more information about that?
Yeah, so I think when you use the word cookbook, you probably hear about grandmother's cookies cookbooks or grandmother's recipes cookbooks, right? We all love those. And so by definition, what a cookbook has is a collection of recipes, recipes that tell you how to create different dishes and how to create different kinds of cuisines that your grandmother or your grandparents used to do. So along the same lines, the API Cookbook is also a collection of recipes, and where each recipe is demonstrating how API users or application developers can use a standard API to do common tasks, good things like that are as tasty as the grandmother's dishes. So one of the classic examples I'll give you is that one of the common questions that any end user would have is like, okay, show me how I can use the API to get the part decomposition structure from a system architecture. If you've got a spacecraft and I tell you that I want you to give me all the parts in a spacecraft, or all the optical or mechanical parts in a spacecraft, show me how to do that using API. Another common question that came up is, can you tell me what requirements a specific part needs to satisfy or were allocated to that part, or what behaviors that a part could exhibit? Or for example, can you execute a specific query, or can you help me to create a set of queries that are based on commonly asked questions that a system engineer has? So these are common things, like common things that a system engineer wants to do. And so we started creating recipes for each of these common useful tasks that system engineering teams want to do, and realize them as recipes. And so each recipe is basically a Jupyter IPython notebook, and that uses the REST API for the systems modeling API and services. And these notebooks obviously are executable. When you execute these notebooks, they hit the pilot implementation server that the SysML v2 submission team together has set up, and it executes that recipe and gets you some useful data out of it. And this cookbook is actually publicly available as a GitHub repository. So anyone can go to the GitHub repository for the cookbook and try out these recipes. Just point to one of the pilot implementation servers. Or if you're a provider, or if you have other providers who are providing the implementation of the API, you can just point to the URL to that provider and run the recipe. And if they're conformant to the API, those recipes will run. So our goal is that because we have provided the API at a very foundational level right now, we want to extend it. And Tim talked about extending the API. We want to build a lot of these recipes, and have more and more people come up with their use cases and build a lot of these recipes that makes it easier for API users and application developers to get started with the systems modeling API and services. The other aspect of this problem is that creating the SysML v2 meta model is very harmonized, very neatly developed, but it's also very complex. That could be a big hurdle for someone to understand the meta model before they realize how do you use the API to create it. So having these recipes also provide a good training exercise, starting point, where we could abstract the nitty-gritties of the meta model and say, all right, let's talk in terms of common system engineering use case. You want to create a part structure? Call this recipe function to create a part structure. You want to create a set of requirements? Call this one to create requirements. And the users could be abstracted away from the inner workings of what needs to happen to create a valid SysML v2 model with requirements or parts in it. So that's the way, is to ease the adoption process.
So the recipe sounds a little bit like non-normative services, no? So potential candidates for services.
Potentially, yes, but yes, definitely.
So give me the parts list, no, of or something like that. It could also be a service.
Exactly. So by the way, what we did is we also included the cookbook as part of the SysML v2 systems modeling API and services specification submission to OMG. So the submission actually includes certain recipes, because I think they could be a good training exercise to help people understand how the API works. But as you said, Tim, when we get these complex use cases, our first approach would be, okay, let's develop a recipe to figure out how complex is this use case. And when we see that this is a very fairly recurrent use case, maybe in a future version of the specification, this could change from a recipe to a standard service by itself, because it's pretty common and everyone needs it. So high-level API based on the foundational API that's out there.
Yeah, so if we don't forget it, we will link the API cookbook and the Intercax server and your LinkedIn profile so people can look it up later on.
Absolutely. We would be happy to help.
So, well, I think we asked all the questions, no? Well, I have many more questions, but we are running out of time. But we asked all the important questions we had. So, well, I think it's time to close the session. And yeah, thank you, Manas, for being with us.
Well, thank you. Thanks, and thanks for the opportunity.
Very good.
Come in, Christian.
Very welcome.
And well, our next topic is, well, we have not identified it yet. We have some ideas, but nothing is scheduled. So stay tuned. We plan something in July, but well, it depends on our guests if they are available. And so then close it as usual with, do not forget.
Give us a thumbs up, subscribe to the channel, and trust us. We are systems engineers.
Thanks, folks. Thanks for having us on the podcast. Bye-bye.
Great.
Bye.
Bye-bye.
Take care, everyone.